and this is the horizontal milling machine. Okay, so that has actual horizontal milling machine, just that you can see that maybe actual practice machines that we can see here. Okay, so this is the arbor where that the tool can be holding. Okay, so you can identify the milling cutter is, which is just like fixed here. The arbor is like a spindle which is fixed there, and other end is just like arbor bracket which is supporting that one for not sliding some outside. Okay, and other one is vertical milling machine. So spindle is vertical or perpendicular to the work table. Spindle is vertical or perpendicular to the work table. It has the movements of the table for proper settings and feeding the work. Okay. Spindle work may be swiveled at an angle, permitting that milling cutter mounted on spindle to work on a angular surfaces. In some machines, spindles can be adjusted up and downwards. Maybe there is adjustment for that, maybe tools that are so adapted for machining grooves and slots, and maybe flat surfaces we can able to obtain by this. This is nothing but called as a vertical milling machine. A diagram of only vertical milling machine. What are the major parts existing here is maybe a base, as you know, that for supporting the total machine, column, spindle, and there is a spindle head, knee, saddle, and work table is there. As you know that this is the basis, and here it is a table. On table there is a voice is fixed, and for just because of just like holding the workpiece, and there is a spindle which is just like maybe existing on that, rotating about vertically, rotating just like maybe about y axis. And when you want to generate that, maybe special slots, so that we can just like maybe spindle head and just like spindle, and check we can identify it vice or work table. And we know that knee, and we can able to just like there is a arrangements, wheels are just existing here for movement along the x-axis, along the y-axis, maybe the upward direction and downward direction of that maybe table. That is also possible in this one. So the directions that we can able to see that vertical mission, so that the axis, so x-axis and y-axis, z-axis are shown here. Okay, how that may be along that y-axis that may be moving the tools. Cutting tool is positioned vertical and perpendicular to the work table, as you know that. But in earlier case, that is parallel, and parallel to that may be work surface, horizontal or parallel to the work surface. But here it is a vertical or perpendicular to that may be work surface. The movement of the table left and right is on the x-axis, towards that may outward maybe just like that we can on the y-axis, right? And this is the difference between that maybe horizontal and vertical milling machines. So just what are the differences between the horizontal vertical milling machine? The first difference is spindle is horizontal and parallel parallel to parallel to the work table. Spindle is spindle is spindle is vertical and perpendicular to the work table. And second point is cutter cannot be moved up and down. In vertical machine, cutter can be moved up and down. And third one is cutter is mounted on the arbor. And third one in the vertical milling machine is cutter is directly mounted on the spindle, right? And fourth is spindle is called as spindle cannot be tilted. So in the horizontal machine, it is not possible to tilt it. But in case of vertical machine, there is a possibility of tilted some with some angle that based on the requirement. And some machine has that arrangement, but some machine may not be have. Okay. And operations such as plain milling, gear cutting, form milling, saddle milling, gang milling, and like that, just we can able to obtain maybe just like perform the by horizontal milling machines. But for vertical milling machines, we can able to use that maybe operations such as slot milling, T-slot milling, angular milling, flat milling can be performed, and also drilling, boring, remaining can also be just like carried out, right? So this is the universal milling machine. So when compared with that, maybe horizontal, well, universal is maybe just like somewhat different. So the plain horizontal machine is additional tables swiveling. The table also we can able to swiveling it. Housing performs the table able to just like swiveling around 45 degrees either direction in the horizontal plane. Usually the milling of helical groove twisting drills and milling cutters and just like gear cutting purpose, so that we are using that maybe universal milling. Okay, so these are directions we can able to move with this universal milling machine. Can also be used as that horizontal and vertical milling machines. We can able to use it that universally is both the horizontal as well as vertical. And mainly it is a horizontal milling machine. but can be also just like used the vertical milling machine by fitting the vertical head. We can fit that vertical head. We can able to use that it as a vertical milling machine. The added advantage with that universal milling machine is that the work table can be turned to an angle in the horizontal plane, that we can able to just like tilting that may be workable. But vertical milling machine we can able to just like tilt that only the spindle head, the tool head only, right? And what are the operations that we can able to perform with that maybe milling machines? So what are the operations that we can able to perform and carry over that? So the plane and slab milling process, face milling process, end milling process, side milling process. We can able to generate the slots regarding that maybe keyholes or something else. Angular milling process, form milling process, and steradal milling process that we can able to just like perform by using that milling operations. Okay. And milling operations that may be slitting or saw milling, gear cutting operations, keyways, just keyways already we have discussed milling operations, and string milling operations, profile milling, thread milling, and helical milling and cam milling, like that, just various operations we can able to perform by the milling operations. But some of the milling operations we can able to perform with that maybe lathe machines, but it is not that much professionally, it is not that much devoted for that maybe milling operations. So the first operation is plain surfaces or slab milling operations. So here we know that the cutter has multiple cutting tool, and the tool workpiece which is just like we can able to plain surfaces we can able to obtain it, maybe some slabs. So process to get maybe flat surfaces of the workpiece in which the cutter axis and maybe workpiece axis are parallel. The primary motion is rotations of the cutter. So the fed is important. And so particularly this is in this case we are using that maybe horizontal milling machine. The plain milling cutter that we are using that maybe horizontal milling machine. And the second operation, so just we can plane surface and slab milling operations. So that maybe a workpiece, just we can see that maybe plane mill cutters, that side view, and which is maybe a lengthy cutters are there. Width of the cutter is more, at the time we can use it. Okay. Face milling operation, so that the tool is maybe just like vertical, rotating about vertical, and the operation is carried out producing the flat surface which is perpendicular to the rotation axis of the rotation of the cutter. It is perpendicular, the workpiece is perpendicular to that one. Okay, no. So that time just we can use that my face milling operation. Particularly we are using that vertical milling cases, we can able to perform the face milling operations, right? And so this is the face milling operation manufacturing, that we can just like obtain the surfaces how we are rotating about the vertical directions, that we can see that in detail diagram, right? Then end milling operations. So and performed for producing the flat surfaces are key slots and grooves, and particularly finishing that edges of that work pieces, so that we can use that maybe L mill cutter. Particularly the machine is that we are going to use this vertical milling machine we can use it, right? This is the end milling operation. And then side milling operation. So the side milling is operations performed for producing the flat surfaces, slots, grooves, or finishing the edges of the workpieces. Okay. So here the side milling is operations performed for producing the flat surfaces, slots, grooves, or finishing the edges of the workpieces. And that we can call as end milling cutter, we can use it. But here the machine that we are going to use for the side milling is that one, some part is just like we are going to remove it. So that for that purpose we are going to use that way horizontal milling process, horizontal milling machine. Okay. And this is the, when you want to generate the slot means slots. So operations of producing with maybe just like slots like a T slots or plain slots when you want to generate it. T slots or plain slots when you want to generate it. So the end cutters are T slot cutters are just we are using it. Basic machine that we are using it may be vertical milling machine. So basic milling machine that we are using it, vertical milling machine, right? So these that maybe just we can call it as a T slots, that we can able to just like cutting with the T slots, and that T-shaped end cutters are there. Same way that we are going to use that maybe vertical milling machine that we are going to use it. Okay. Then angular milling. So how that angular milling is used? Okay. Angular milling, just like maybe the tool itself maybe is some angular shape, like angular biology shape it is. So that angular cut is which is fixed on that maybe horizontal milling machine. So we have a double angle cutter is there. Double angle cutter is there. The operation of production of that types of angular cuts like a V cut, V notches, V grooves, and serrations and angular surfaces when you want to obtain it. So these are the cutters, and this is the arbor and workpiece. So for that, just we can double angled or maybe single angled angular workpieces are that tools are used on the workpieces to obtain the required shapes, right? So this is the angular milling operation. And form milling. Form milling means it is the irregular shapes that we need to. Sometimes maybe elliptical shape. Sometimes we need to just like maybe semicircle shape, and sometimes maybe just we can maybe a different grooves we need to cut it. Operations of that maybe producing the types of angular cuts like V notches and grooves, serrations, and maybe angular surfaces, and which may be curved surfaces that we can use just like use that maybe double angle cutter or maybe curved shape cutters that we can call as a form cutters. We are using that. So here also just maybe milling horizontal milling machine. The tool is mounted on the horizontal milling machine, but the shape of the tool is different. The shape of the tool is different based on that maybe form of just like groove that we need to obtain it. That is nothing but called as a just like maybe form tool, right? And steroidal milling. Steroidal milling means both sides when the surfaces when you want to just like obtain the both sides side cutting is just we need to obtain this simultaneously. Okay, so the two cutters are arranged. Operation of the two parallel surface simultaneously on the workpiece. So we are going to use that maybe two cutters, two or more side-facing milling cutters are just like we can arrange it. So these also maybe arranged on the arbor or spindle. Just we can call it as arbor. Arbor in that maybe horizontal milling machine. Okay, so like these type of operations we can able to effectively carry over it, right? And then other one is gang milling process. So more than one, maybe just like a group of cutters that we are going to use it process to get the different profiles on the workpiece simultaneously. We can cut down that maybe different profiles, maybe more than one, so that we can call as a gang. Different cutters are required, maybe different types of maybe sizes and different shapes, different forms are which are mounted on that maybe arbor of that horizontal milling machine, so that operations can be carried out as usual. So the next operation is pocket milling. Operation. So the pocket milling is operation another form of end milling used to mill and shallow the pockets into flat parts. Okay, so the pocket milling is another form of end milling used to mill shallow pocket in flat surface flat parts, right? So these are just like maybe special pockets when you want to obtain it. The time just like the tool is arranged in like this. So definitely here this is just like fixed in that maybe the spindle head of that vertical milling machine. And there is a surface contours we need to generate it. This is also vertical milling machine, but the a ball nose cutter is fed back and forth of the across that work along the curvilinear path at close intervals to create three-dimensional surfaces. To create the three-dimensional surfaces, right? And this is a milling cutters. So these are the just that are the general operations that we can able to perform by the milling machines. Okay, and also the milling cutters also classified based on the requirement. So this is nothing but first one is called as a plain milling cutter, and second one is called as a and face milling cutters. So which is fixed on the vertical milling machine, and side milling is also just like fixed on horizontal milling, and single angle, and just we know that maybe double angle, like just like when you want to obtain that maybe half V and full V notches we need to create it. These are the notches we can able to create it. Okay, and there is a special form tools, pocket tools are there, just we can use it. So these are the special tools, maybe end milling cutter and form milling cutter and T slot milling cutters that we can use it maybe for obtain that maybe T slots. So these are the different milling cutters that we can use it maybe particularly in the milling machines. Okay, so these milling cutter tools are maybe fixed on that a spindle like that we can call as a arbor. Okay, and similarly, just we are using that with so many other classification, rough and milling cut, and as well as slab mill cutter, and L mill cutter, N mill cutter, ball mill cutter, just which are used that maybe contour shapes, and hollow mill cutters that are used just like wood rough cutting maybe threaded portions we can able to update. Fly cutters are just we can use that maybe face milling cutters, and invalid gear cutting maybe for gear cutting operations that we can use it. and as well as maybe hobbing cutters are there, dovetail cutting, and just like side face cutters also just we can use it. These are the different classification of the different types of the tools that we are using in the milling machines, right? Okay, and familiarly just we are going to use that maybe the milling mechanism is used for that obtaining the gear mechanism, obtaining that maybe gears mechanism. So particular that maybe gear manufacturing. Okay, so manufacturing is particularly we have to just like obtain the profiles, gear profiles on the circular disc equally. So suppose we need to just like divide that maybe circular disc equally. How it is possible when you are divide with it maybe just like generally maybe manual? It is not possible just like equally. There may be just like uneven division is possible. That's why. So when you are making the gear profiles with that uneven specifications, definitely it cannot be matched with that maybe other gear for maybe just like power transmission purpose, which is where we are going to use it. So the gear trains which are used maybe power transmission if the two shafts are very near. Okay, and the gear teeth which is engaged with that maybe other gear. There is a follower gear, a driver gear, driven gear. Okay, thereby the power is transmitted. For obtain maybe just like perform that maybe just like obtain the gear profiles on the circular disc, obtain the gear profiles on the circular disc. So definitely we are going to use that indexing methodology. So that definitely we are going to use that maybe some indexing methodology we are going to use it. Maybe indexing methodology which is attached to the milling machine. So you can raise the question why that indexing methodology is only just like attached to because here we are going to just like maybe creating the slots or splines generation, maybe equal slots maybe around the circumferential of the round rod, and also maybe gear profile cutting on the circular disc. So we need to just like obtain equally for equal arrangement of gear profiles. So we need to follow that maybe indexing methodology. Okay, so indexing is a method of dividing that periphery of the pieces of workpiece into any number of equal parts. Any number of equal parts. That means the periphery of that maybe workpiece. So we are going to divide into any number of. So is it 6 or 7, 8 or 9, maybe equally, not uneven. So if it is not specifications are that maybe module and the teeth size is not equal of all the gears, maybe may not be matched with that maybe other maybe follower gear. So that maybe cannot be possible to just like power transmission. Okay, there is some other problems will be backlash or some errors will be occurring on it. So the attachment used for performing the indexing is known as the indexing head. So definitely we are going to just like attaching that maybe indexing in milling machine. You can in our laboratory we can able to observe that there is a special arrangement indexing mechanism is attached to that milling. So the function of dividing head in is to divide the periphery of that work piece into any number of equal parts, either 5, 6, 7, 8, based on that. Okay, to provide the continuous rotary motion to that maybe job during the helical milling process, to set that workpiece in a desired position in relation to that maybe machine table. So we need to just like set that workpiece to the desired position. Based on that maybe that cutting process can be so that gate proper slots can be able to generate either splines or maybe gear cutting process. So acts both that holding also supporting device for the work during the operations. The indexing operations can be adapter for cutting gears, ratchet wheels, and keyways, fluted drills and taps and reamers. And the indexing head serves as an attachment for holding and indexing that maybe holding of that maybe particularly doing that maybe about task. So we are going to divide that maybe circular disc equal parts. So for that purpose, we are going to index it. So that is just we can call it universal dividing head arrangement on the milling machine for obtain that maybe gear profiles. So on circular discs and as well as maybe splines maybe equally arrange that maybe slots on that maybe particular parts. Okay. So indexing of milling machines. So indexing is the process of evenly dividing the circumference of that circular work pieces into equal space divisions. Equal division. That is the major part. It is used to cutting the gear teeth, cutting the splines, milling grooves and reamers and taps, spacing holes, or maybe equal. Sometimes the circular disc has maybe just like there is a flange cutting. Flange pipes are there. In the flange pipes for assignment of that bolts and nuts, that holes are arranged evenly throughout the circumference. Okay, that holes we can able to arrange that maybe bolts, that we can just like equally arrange that maybe bolts. That time also we can use just like indexing. Okay, and now just you can see that this diagram. So division of that may be equally equally. So that based on that, maybe once divide on the circumference base, and the cutting process will be carrying by using that cutters, maybe they shaped cutters, double angle or V shaped, or maybe profile, maybe profile cutters are used for particular gear, profile cutters are used to carrying that operations, right? And what are the indexing methods so that you can use? So what are the indexing methods? You can choose it. Choose of methods depends upon the number of divisions are required. One is the direct, and second was the simple and angular differential, based on requirement. Based on requirement. One case we can use that maybe direct indexing method. Another case we can use that maybe simple indexing, and maybe angular indexing. Sometimes maybe just like differential index. Based on that, maybe based on that, maybe suppose if the gauge size is more, that may have one method is not suitable for that. Okay. So when you are using that first one, direct and rapid index, first method, direct or rapid indexing. Okay. So the direct indexing sometimes is referred as a rapid indexing. So which is the simplest method of indexing. Okay, we can use just like equal to simplest method, we can use it. The construction of some indexing heads permits to that worm to that maybe disengaged from that worm wheel. There is worm and worm wheel attachment is there. So based on that maybe rotations. So based on that, that can be just like the table, that workpiece which is fixed on the table can be rotated properly based on that maybe required calculation, making possible quicker method of indexing called direct indexing. So the dividing head fitted directly on the spindle, so which is directly fitted on the table, just like directly we can able to just like we can able to mark it in the marking. So indexing plate has 24 holes, that is a temper, and the periphery of the jobs we can able to divide two pieces, which is a divisible for that one. So that is 24 by 2, and two times we can just like three pieces 24 by 3, and 4 24 by 4 6, and 24 by 8 and 12 equal parts we can able to divide it, because it is a indexing plates consisting of that maybe 24 holes. So we can able to just like do that, divide the 2 3 4 6 8 and 12 equal parts directly. So this type of index is most commonly used for indexing fixtures, indexing maybe indexing fixtures and maybe for particular purpose. So these are that maybe direct indexing. Sometimes maybe just we are discussing of the one plate, maybe slot plates will be vary, different plates, 24 slotted holes plates are there, circle plates are there, maybe 30 holes circle, maybe 36 holes, maybe we are familiarly using that 24 holes. Number of divisions possible by indexing, maybe suppose if it 24, and direct indexing methods that divisions is possible. So and these numbers which you can able to just like divide the 24 2 4 2 3 4 6 8 and 12 24 we can able to divide. Similarly 30 2 3 5 6 10 15 30 for 36 plate, 36 whole plate. So we can able to divide that maybe parts like 2 3 4 6 9 12 18 36. So this is the direct indexing method. Direct indexing. So the direct indexing method arrangement is like this. Okay. So here the job is arranged like that, and warm and warm mill connected like that. So indexing plate, based on that maybe arrangement, when you are rotating it, the positioning of that workpiece will be keep it as per requirement. And once it is positioned, the milling cutter will be cutting process on the slots can be generated usually. Okay. So that's why it's directly we can able to rotating that maybe workpieces. Okay. And other method is simple or plain indexing method. Other method is simple or plain indexing method. Some cases, suppose if 24 plate is there, if you want to just like divide that to 24, if it's 7 parts we need to obtain it, it is not possible just like using the direct indexing method. At that time just we'll prefer that maybe other indexing method mechanism, that is called as a simple or plain indexing mechanism. So in plain indexing, the dividing head spindle is moved by turning the indexing crank. Okay. As the shaft carrying the crank has a single threaded worm, and which measures with that maybe worm gear having the 40 T's, that is standard, and 40 tons of that crank will necessarily rotate the indexing head spindle through one revolution. For one revolution, we need to just like rotating 40 tons of that maybe teeth. Okay. To facilitate indexing fraction of the turn, So indexing plates are maybe used to cover the practical all numbers. Okay, so this is the mechanism that we are going to using for that simple indexing or maybe plain indexing. Okay, so this is nothing but called as a indexing pin here, indexing pin, and this is called as indexing plate, which has a number of different holes existing on that, and that where we can just like by with the help of indexing pin. So there is a sector arm which we can just like marking for marking purpose for identification of that position of that one, and we can arrange fix it on that one hole and just making the marking for that one, and we can able to rotate it. So based on that we can able to rotate it, the maybe how many 40 runs or maybe just like 1.5 run or 2.5 run based on that. So just like maybe quarter run, half run, based on that we can able to rotate it, right? So we can mark that on the what this is nothing but called as a warm. This is nothing but called as a warm shaft or warm single threaded, and this is a warm wheel with a 40 teeth which you have. Okay, at the end of this there is a indexing spindle is there. On that we can fix that workpiece we can able to fix that on that workpiece. Okay, and based on these movements just we can positioning the workpiece and mark it with that various markers. And once it is marked, then we can start that maybe milling cutter will be carrying the process of profile cutting. So this is the general arrangements of the different tools that we can. So that is just like we are going to use that maybe suppose when you want to divide that maybe two divisions, 40 by 2. So when you are going to divide with that maybe four divisions, 40 by 4. When you are going to just like 10 divisions, that is 40 by 10. Because so why you are just like using the 40 standard, a 40 teeth wheel is there, one wheel is there. That's why it is just like we can divide it. So if n divisions are required, just the time just like 40 by n turns are just we can use it. Okay, 40 by n turns are we can use it. Okay, number of divisions we need to obtain, that is nothing but called as a n. Okay, so some cases it is not possible just like divide by these simple or plain indexing methods. Plain indexing method, like just suppose when you want to just like when you're taking the simple problem, required division of n 60 parts, that is a 40 by n. So just we can just like 4 by 6, that is 2 by 3. So we can divide maybe 2 by 3, multiply with that maybe numerator and denominator by the 6, 12 by 18. So on 12 holes on 18 hole circle, just like we can just like for every 12 holes we can mark it on 18 hole circle. Okay, so like that maybe we can able to obtain. Similarly, suppose when you want to number of divisions we need n 35, that is 40 divided by 35, 8 by 7. So which is just equals just like maybe mixed fraction. So that is 1 by 7, that is 8 by 7. So just multiply with that maybe 3 by 3. So which is 3 by 27. So one full turn and three holes movement of on three holes on the 21 one circle, three holes on the 21 circles. Like that we can mark it and just like based on that position it and place that sector arm, and just we can mark on the workpiece. Again we can move to that maybe same one ton, and as just like and after one ton three holes on the 21 circles, and again we can mark that maybe. Like that the divisions are formed. So thereby we can equally divide that maybe the particular surface. Like just we can, and 27, if it is 27 just we have that maybe 39 holes on the 81 circles, and with a one fill maybe just like 27 by n, 40 by n, 40 by 27. So which can be divided 39 by 81. So one full turn, and 39 holes are moved on that 81 hole circle. Like that these are the general operations. And other one is we have a differential indexing method. Some of that divisions which are not possible to just like dividing that simple indexing, or simple indexing, and as well as direct indexing, which is not possible. So at that time just like 127, 188, maybe just like huge type of huge divisions are required. At that time just we can use that maybe differential indexing mechanism. So where that crank pin or indexing pin is just like existing on that. So there is a gears attachment, compound gear arrangement is there, and as usual remaining is warm wheel which is connected with that maybe warm shaft is connected to warm wheel. As that can be rotated, workpiece is at the end of that particular warm wheel we can fix it, and based on that the marking process will be carried out. So the standard formula for in the differential is a minus n divided by a into 40. where A is that assumed value before and after, maybe n, maybe nearest to, maybe assumed value closer to that, maybe that n value. N is the number of decisions that we are going to be obtained. Okay. So gear ratio, we know the number of teeth on the driver to the number of teeth on the driven, gear ratio. Okay. So like that, just we can able to just like maybe by using substituting, suppose 127, so the 61 we are going to just like, so nearest number is 60 minus 60, 60 minus 61 divided by 60. Okay. So that we are going to 1 divided by 60 into 40. Based on that, the gate ratios will be find out. So which is 1.5 or 1, and maybe which circle plated circles we can select it. Just like it is maybe extension of this one. Okay. And other method we are going to use that maybe angular. So which is equaling to 360 degrees. Just we can divide by. So the 13 9 degrees, that we can just like obtain that maybe angular indexing method mechanism, right? And next one is estimation of machining time. Machine time, that is also very important. So for my calculation of the maybe production cost. So estimation of machining time on particularly milling machine. So what are that maybe general scenario that we are following? Total length of the job to be machined. Okay, definitely. Suppose when you are considered this is a part, maybe a plain or slab milling cutting is there. So there is approaching length. Just before going to contact that wheel, cutter will be moving before that work surface. That we can call it the approaching length. And after cutting also, which can just like overrun it, that overrun length. So that is that approaching length. Just we can call it as the L1, and over length, the run length, which just we can consider as maybe just like L1, and that maybe just like LA and LB, and just like number of cuts. That is just like number of cuts we can able to find it. So breadth of that maybe cutting and divided by F. Breadth of cutting divided by F. Breadth of cutting divided by F. Okay, B by F. Okay. So the F is nothing but called as feet per pass that we are going to give in that. So based on that, maybe how many passes are required, how many cuts are required, that we can able to decide. And cutting speed, we can able to calculate it, and V equals to pi dn by 1000. Amount of feet per minute. So that also we can be able to calculate it. The total length equals to, so workpiece length plus approach length plus overrun length. That is L1 plus L2 plus L1 plus L2 plus L3, that we can able to consider. Okay. So like that, maybe length of the job to be mentioned, and L2 is the approach length, L3 is maybe overrun length. So L is nothing but equivalent to L1 plus L2 into L2. Okay. Where D is that maybe diameter of the milling cutter, and D is that maybe small d is the depth of cut. Okay. So like that, just we can calculating the L2, D minus D2, by using these relations we can find it. Okay. And L3 also just 1 to 6 that we are going to consider. Okay. Total machining time is T equals to L into N divided by F by N. So L is that maybe total length, L1 plus L2 plus L3. So N is nothing but number of cuts, B by F. Okay. Feed is just like F is the feet per minute. That based on that we can able to calculate it, right? So like that, just maybe substituting all these values, we can able to find out that machining total machining time with these relations, right? So this is the general aspect of the milling cutters and types of milling cutters, and maybe classification of milling machines, and that working principle of millings, and as well as maybe how to calculate the machining time for the milling operations, right? Okay.